In most programming languages, we have a concept called a multidimensional array. You could think of a two-dimensional array as a table, where each cell of the table holds the same data type, and each row of the table is the same length. So this would be a 3 by 7 two-dimensional array. Maybe we call it my array. And depending on the programming language, we might access the elements of the array like this, where the first number is the row and the second number is the column. So my array 2, 4, remember we start counting with 0. So this would be 0, 1, 2, 0, 1, 2, 3, 4 would refer to the number 2. Or it might look like this. Multidimensional arrays still have those properties that they occupy a contiguous space in memory, they have to hold the same data type in each cell, and they are generally hard to extend. Usually you could have any number of dimensions for a multidimensional array. It's just hard to picture by drawing it out. In Python, we don't have a built-in data type of an array, so it's not surprising that we don't have multidimensional arrays either. Instead, we'll talk about lists of lists. And let's just write out an example to get us started. Suppose we want to represent a simpler table like this. We can initialize a list just as we did before with a square bracket, but inside we'll put another list, another set of square brackets, and then the numbers 1, 7, 4, and a second list with the numbers 3, 2, -1. Python is actually creating 3 objects here, 2 internal lists, and the external list that contains references to the first 2. So my list is a list, but my list with the index 1 is also a list. It's this list in here. When we dereference my list with the index 1, what we get is the list 3, 2, -1. If this is a list, then we can just add another set of indices on it to dig deeper into the inner list. So to get the number -1, for example, we would write my list 1 for the inner list, and then 2, remember, 0, 1, 2, to access the third element in that inner list. Now, I wrote this as a table with 2 rows of equal length and the same data type in each cell. But of course, Python doesn't have those restrictions. So we're free to, for instance, replace the -1 with cat. And that's perfectly fine with Python. Now we have a list of lists, and in the second list we have 3, 2, and the word cat. We could even have a list in the first position and a float in the second position. Let's go over to PyCharm and see how that works. Again, for simplicity, I'm going to code all this at the module level. Let's go ahead and print this out just as a start. And let's access a single element. In the first inner list, let's access the second item. In computerese, we would say, in the inner list in position 0, we're going to access the item in position 1, because we always start with 0. So we're going to try printing my list 0, that's the first list, and 1, which is the second item in the first list. Let's print that, and we get the number 2. Of course, we can change that. And let's just demonstrate that we can mix and match data types inside here. Let's change that to cat, and then we'll print it out again. Let's look at the whole list. And we see that the string cat is sitting happily among all these integers. We can replace this second list with a list of a totally different size. So in that case, we would access my list with index 1 to indicate that we're interested in this second list. I'm not going to put a second dimension here because I want to change this whole list, and I'm going to change it to a shorter list. And we get what is called a ragged list, meaning not each row has the same length, but that's totally fine in Python. What's actually happening, for those who want a little bit of a deeper knowledge, is my list is a list that contains 2 elements, and each element is a reference. When we first created my list, the first reference was to this inner list, and the second reference was to this inner list. So Python is creating these two lists in memory as objects, and then inside the third outer list is just creating references to each one of those objects, just pointers to a place in memory, so that it's super easy to change the place one of those references is pointing to. We just create a new object and say, hey, I don't want to point to this list anymore. Now I want to point to this list. In fact, we don't even need to have lists in every position. We can say my list 1 equals penguin. Let's print it again. So we've created a new string object named penguin, and we've said, okay, in my list, I want that position 1, instead of pointing to a list, now I want it to point to this string. No problem. That does make Python a little more flexible. Let's go back to our original list, though. I'm going to delete all of this. We might find that often we want to iterate through a list like this. Maybe we want to go through and print out each individual item on its own line. Let's use a for loop for that. So notice I'm iterating over my list, which is a collection. It's iterable. What am I going to get out of this? Remember that my list actually only has 2 elements, its first position and its second position. So as I iterate, the first time through the loop, I'm going to get this object, 425. The second time through the loop, I'm going to get this object. So row in each case is actually a list object. Again, the list object is iterable, so let's iterate through that as well. And then we'll print out the item. Let's use an F string. And we'll run this. We get what we wanted. So in this example, we're really mimicking an array. We have a rectangular table where every item is the same data type. But remember, lists are more flexible than that. We might have a data set of the pets in our home. And the inner lists may each have a type of animal, the animal's name, and the age. So notice that we could not represent this as a multidimensional array because the data type is inconsistent. But each row is still the same length, and the columns really represent something. The first column represents an animal type, the second column represents a name, and the third column represents the age. So it's very useful to organize data in this way. And we might say, so now we have a program that can dig into this list and in an organized way, iterate through each row and pull out the important information, presenting it to the user. In real life, we probably wouldn't hard-code the assignment of this list, but maybe pull all of this data from fields in a comma-separated value file or a query to the internet.